So my name is Jeff Hunter. I am a technical marketing manager at VMware. Don't let the marketing part scare you. Focus more on the technical part, if you will, please. We're going to focus on some HA best practices today for lack of a more formal title. You can obviously see the title up there, but this is all about making sure that your virtual machines maintain the highest uptime possible, and more specifically for unplanned downtime with the vSphere HA components that are in there. So some of the things we're going to focus on are recent enhancements to vSphere HA. We'll get into networking, storage. We'll talk about admission control, isolation policy, all those types of response. And if we have time, and that's a key operative right there, if we have time, we'll get into a little bit around the virtual machine monitoring and application monitoring features that are in vSphere HA as well, and maybe even, just even, potentially a sneak peek at what the future of vSphere HA looks like there a little bit. But again, that's assuming we have enough time. So anyway, speaking of that, if by some chance we don't get through the entire conversation here, we leave out a few spots, or you have additional questions or concerns or comments, and again, we run out of time, just as a footnote, Josh and I will be at the demo booth down on the show floor, the VMware demo booth down there from about 4 o'clock until 5, so basically the last hour of the day that the show floor is open down there. So we encourage you to stop by during that time as well. Again, if you don't get your question answered or we run out of time or whatever the case might be there. So make sure you stop down and see us. We even have a demo down there that we can show you as well around some future HA possible capabilities we're thinking about. So without further ado, let's go ahead and dig into it. And actually, I want Josh to take a moment as well. I introduced myself. Josh, if you would like to tell folks what you do at VMware, please.
And to balance out any presentation, Jeff is the marketing guy here. I'm the guy from support. So I'm an escalation engineer in our GSS Global Support Services division. I focus on the system operations area, and that's the general vCenter management layer. And my specialty area is availability, which includes HA, which we're speaking about today. Oh, and if you see me checking my phone right now, or in speaking to any of you, I do apologize. I'm not being rude. My wife is very pregnant, and I may need to run out at a drop of a hat. So I do apologize for that. I've had to do that in,
Is this your first one, Josh?
It is, yeah.
Woo! So. How many dads out there like, holy cow, watch out, brother. So let's go ahead and dig into it here. So first of all, the disclaimer slide. Naturally, we need to show this here. As I mentioned before, there's a potential we will show a few things toward the end of the discussion that may or may not be available in future releases of vSphere HA specifically. So by requirement, we have to show you this slide here. I'm not going to put it up very long. You've seen it before, I'm guessing. So again, what we're digging into here really is one of the three pillars of IT business continuity. There are three pillars that are associated with that. One is disaster recovery, and a lot of folks think of Site Recovery Manager when it comes to disaster recovery. There's also data protection. We had some exciting news here at VMworld around that as well, as we just announced vSphere Data Protection, a new backup and recovery appliance that is now included with vSphere Essentials Plus and higher. If you haven't heard about that, I can tell you about that as well some other time. And then last but not least, though, is the high availability pillar of that section there. And naturally, that is what we are going to focus on here. So the beauty of HA, and this has been the case from its original inception. And by the way, we have one of the engineers in the room that really started the HA coding here. So Keith, if you want to raise your hand or stand up just for a second, if you want to talk to somebody that knows HA, this guy wrote the stuff, okay? So make sure you get a chance to talk to him too if you have some deeper questions that don't get answered in this conversation. Smriti is here as well. She is part of the HA team and just as knowledgeable, so we've got you surrounded. Hopefully we can answer all your questions here.
And we wanted to mention the Global Support Services division just briefly. I know we have a lot of content, so I'm not going to spend a lot of time on this. Just know that we have support centers throughout the world. I'm sure many of you, if not all of you, have spoken with us at one time or another. So just know we have a team of tech support engineers back home. I'm from our Colorado office. It's wonderful in Colorado, but don't go there because don't tell anyone it's wonderful. But they're throughout the world, and we're here to help you. If you are having any technical problems still that you need to talk to somebody about, come find me. I can answer your questions, or I'll connect you to somebody that can. We have an expert booth at the Expo Center that we're answering questions. We have people staffed there from all subject matter experts answering questions all day long, every day. So come find us if you have questions.
Perfect.
So first we're going to talk about some recent enhancements that have been released in our HA software over time. Some you'll know about, some this will be the first time you're hearing about it, okay? So first, in 5.0, we entirely redesigned what HA does. We released the FDM Fault Domain Manager component, and really this was to increase the scale and reliability of HA. One way it does this is with the model of incorporating a single master with the multiple slave relationship. Prior to that, we had the 5 primaries and the rest being secondaries, and one of the issues was there's a slight possibility of no actions being taken during an outage if all 5 primary nodes died at the same time. Let's say they're in the same rack, and you didn't architect it so that you could work around that. That was one thing that could definitely happen. Additionally, with this release, we no longer depend on DNS to function. It communicates over IP now, so that's great. It was very common. Customers would maybe misconfigure DNS, or you're deploying a new host and you forget to add it to DNS, and HA had lots of problems with that, with a huge number of customer calls on that. Previously, lastly, we have the additional transport method of being able to speak over the storage in addition to the network. And with that is the data store heartbeating concept, which Jeff will touch on briefly. But come see us in the booth. We're demoing that as well. So in 5.1, which we're announcing this week, we really only have minor updates for you. Previously, with auto deploy, you had to bundle the agent. You had to go through those steps to bundle the agent. That's now included with it. Additionally, this is one of the bigger ones was you can configure the slot size for admission control by hand in the web client now. And I'm going to speak to that a little bit and show you how it works and how you had to do it previously. And one of the bigger ones that we've introduced in 5.1, oops, sorry about that, was we're improving how we handle storage problems. So if it's an all pass down or permanent device loss issue, the previous behavior didn't really respond to that too well. So we've really improved that in 5.1. It is available in 5.0 Update 1, but you have to turn it on by hand. In an update release, we don't change the behavior of our products, or we try not to deeply. So you have to find the configuration options and turn them on by hand. There's KB articles on that if you're interested.
Yeah, so just to be clear, those enhancements are for handling a permanent device loss. So in other words, more specifically, when there is an issue such as the storage administrator unmasks a LUN from your host, right? Or maybe another situation there where there's still communication with the storage infrastructure, so it's able to communicate back to the host and provide a SCSI sense code saying that device is no longer available. That is what those advanced settings that Josh is talking about refers to. So when it comes to all pass down, though, we're still kind of in the same boat there, but stay tuned. Those are things that we are actively working on.
And Keith Farkas is giving a presentation today at 1. That goes into deep details on that. It's really great.
Yeah, I saw the presentation yesterday afternoon. Highly recommended for sure. So to get into some of the recommendations, best practices, if you will, we'll start with networking, right? Some of these are 101 stuff, for lack of better terms, such as redundant networking, although we still see out there some customers fail to do this properly. So make sure that you have redundant networking paths from your host, specifically for your management network, back through your entire network infrastructure. So not only at the host having multiple NICs and configured for communication out those multiple NICs, but also back through multiple switches all the way back to the core if possible as well. And the idea here, again, is to eliminate that single point of failure, right? As long as HA can communicate with the other hosts out there, even if one of 2 links or more links are lost, we're still in a good place. So again, make sure you have proper network redundancy there. Also minimize the number of hops out there. And I'm guessing with most of your data centers and organizations out there that this is probably not an issue. But again, the idea here is fewer hops means fewer devices between each of the hosts and vCenter itself as well. again, to minimize the potential for that single point of failure. Keep things simple. You notice that's the last bullet on my slide there. I live and die by that saying almost literally. I think it's just best if there's no good reason to make something more complicated, then don't do it. Just keep things as simple as possible. And that route based on originating port ID policy is an example of that. You know, I have talked to customers who have tried to get a little fancier with their networking. For example, they may enable Ether channel, for example, to hopefully provide more redundancy there. And quite honestly, probably not necessary. Probably not necessary. Just go with the defaults that are built into vSphere there. And again, stick to the basics. Keep it simple as far as doing failover with your NICs. Failback policy set to no. This is if you do not have the port fast enabled there. And the idea behind that is if we do a failover from one NIC to the other, in some cases, again, if port fast, for example, in a Cisco environment is not enabled, what may happen is when the NIC fails back over to the original, or when your network connectivity fails back over to that original NIC, there may be a situation there where the link is showing as up, but we're still not forwarding packets yet because we're working on making sure that there is no loop in there, right? So making sure that the spanning tree protocol is taking care of no loop situations. So it may be 30 seconds or so before packets are starting to forward there. And what could happen is if the NIC fails back over, HA could say, well, I'm still not hearing anything, even though the link's up, and potentially start doing some failover. So again, just something to keep in mind. Not as common as it used to be. I think most shops have that mechanism enabled for their edge switches where it immediately starts forwarding packets, but something to be aware of in case that is not the situation in your environment. Make sure the MTU size is the same across the board. Again, corner case scenario. Most of you are probably already in that boat, but again, something to keep in mind as we have seen a few calls on that, I suspect.
Yep.
Again, keep things simple. Next slide. Again, 101 stuff here, but we've seen it, so we feel the need to cover it. Make sure that port group names, network labels, those types of things are consistent across your hosts. Okay? Name everything the same, and make it a descriptive name too. We don't necessarily have that in the slide here, but I think it's a good practice when you're naming port groups, VLANs, those types of things, to make sure that you have a good name. So that way, when someone is looking at the user interface, especially in a larger environment where there are multiple admins, they're not having to decode some kind of a cryptic name. You know, what site it's at, whether it's production, test. Give it a good descriptive name so that way it's easy to decipher, especially in situations where we got to get this back up and running. Use maintenance mode for your host. That's a good idea as well. That makes sure that the HA is in the proper state, if you will. The HA mechanism is in the proper state, not to potentially issue failover situations where it's not necessary. For example, if we are doing network maintenance on a host, put it in maintenance mode, so that way host monitoring is disabled for that particular host there. That way we're not getting false positives, if you will. Okay? It's also a good idea to specify an additional isolation address, especially if you have multiple networks where the management traffic is flowing on those networks. By default, it will ping the default gateway of the host that is out there, but it's also a good idea too to specify maybe an additional address, and especially if your default gateway is not a pingable. So in other words, it won't return a response to a ping. You will have to definitely put something out there, and again, that comes in the form of a network isolation address that can be configured. Also make sure, and this is a no-brainer, that all the hosts can communicate with each other in a very standard fashion. In other words, stick to your standards, configure them all the same, and make sure that all the hosts in your cluster can communicate across that management network. Otherwise, you could run into some partition issues there with HA. And again, keep things simple. So here's an example, and this is probably a little more prevalent in a smaller shop maybe where you have fewer NICs in your hosts, or maybe you have older hosts out there that are still running with not as many NICs available to it. In this particular case right here, I have a very simple setup, and this is quite honestly the lab environment that I have access to, but I'm sure it's out there in someone's production environment somewhere. Literally just 2 NICs in the host here, and the way I have that configured is I have vMotion set up to run on one NIC, and then I also have the management traffic and the the virtual machine production traffic tied to the other NIC there. But these NICs are bound together, so that way if one of those NICs would fail, that traffic will fail over from one NIC to the other, but then fail back once that NIC comes back online. So these are advanced settings you can do within the interface there. So basically making sure that the active adapter, like it's shown in the screenshot there, for the management network is VMNIC 0. The failover adapter is VMNIC1, which means when things are running smooth, all that traffic stays on VMNIC 0. However, in a failover situation where I lose that NIC, I can still route that traffic through VMNIC 1. And in vice versa, I have my vMotion traffic tied to VMNIC 1, but its failover, or standby, if you will, in the interface would be VMNIC 0. So there's a basic example, and there are obviously multiple ways to configure this, but there's a basic example of a good way to provide redundancy for your management traffic.
So Jeff, the key to get across there is that's the minimum recommended configuration that we can recommend. So minimum. So if you're very NIC constrained, this is one way of doing it. Of course, if you have more NICs in a host, it may be best to physically separate that traffic out instead of just simply overriding the failover order.
Yep, great point, great point. So there are also a few advanced options in there, and we kind of hit on one of these already, but I'll start at the top. So the DAS.allow network. This is a way, if needed, to specify which networks that the management traffic, or specifically the HA traffic, I should say, will flow over. And there may be situations where you would want to do that. You can specify those particular networks by that port group name in this advanced setting here. So maybe you have multiple networks that is communicating management traffic, but you want to limit HA traffic, or communication, I should say, to a specific network. You can do that through that advanced setting. Josh, anything to add on that?
No, it's good.
Okay. Moving on to the next one, we mentioned this one earlier, the DAS isolation address there. Again, this by default HA will ping the default gateway that is configured on your host there, but in some cases maybe that is not a pingable address, or maybe you have multiple networks that management traffic is running on. It's a good idea to configure a network address in here in this isolation address section for each one of your management networks, or if your default gateway again is not pingable. So make sure you configure that as well. That will again add to the resiliency and reduce the potential for false positives in the environment.
Yeah, that's important if, like, let's say your default gateway is a firewall. You're separating your traffic that way, and ICMP is turned off on that. That's really common. I see that a lot in customer cases. So that's when you would use the isolation address right there. And additionally, you can add multiple to have good indicators, better indicators, if a host is indeed isolated.
Yep, and to build on that, if that is the situation in your environment, where maybe like Josh said, it's a firewall that does not return response to a ping, you'll definitely need to make sure that you go in there and turn off the default isolation address piece. By default, I believe that is set to true.
Yep.
So in other words, it's going to ping that default gateway, but you'll want to change that to false if your default gateway is not pingable. Okay. Last but not least on the slide here, that failure detection time. That is actually something that has been used quite a bit. I believe that's one of the most common ones you receive calls on.
That's what I've heard.
Up until 5.0. That setting has been deprecated with 5.0 because quite simply there is no longer a need for it. We have the heart beating mechanism in vSphere HA version 5 and above, which really negates the need to have that set in there. So in the past, maybe you've done that with 4.0 or 4.1, whatever the case might be. You've changed that setting to a longer amount of time for one reason or another. There's no longer a need to do that. And besides, if you try to do that, that setting is no longer available or configurable with 5.0 and above. So storage. Let's switch gears just for a second here. And again, some similar themes. Redundancy. Again, it's 101 stuff for most of us. We know that we need to have multiple paths of storage, but once in a while we see that is not the case. So again, make sure that there are multiple paths, not just from your host to the switches that you may have out there, but all the way back to the storage array itself. So make sure you configure redundancy there, so that way if one path at any point in that path goes down, you obviously have another way to get to that back-end storage there. I'm sorry, I thought you had something to add.
No,
okay.
Just, yeah, all the best practices for storage in general apply. Nothing too special for HA there.
Yep. And then last, the multi-pathing policy too. Again, I don't think we see this as often, but back in the day, maybe with some older arrays, we would have the wrong pathing policy set up where you would see the path flat back and forth between storage controllers. Again, not as common this day and age, but still possibility. So again, make sure you have the right multi-pathing policy set up in your storage environment. So we talked about the storage heartbeats, and again, to dig into that just a little bit further, we've added additional capability for HA to detect and properly react to a situation where a host may be down or isolated, or there may be a network partition there, and that is done in part through the storage heartbeat. So in addition to management traffic through the network, the host management network, in other words, we also have the ability for HA to talk amongst itself, various hosts, in other words, to through the storage. And this is in the form of storage heartbeats down there. So, for example, when you configure vSphere HA in 5.0 or above, and by the way, I have a quick question. I know you've probably had a lot of polls and raising hands up to this point, but I'm very curious as to how many folks have made it to 5.0 or higher. Do we have a lot of folks running 5.0? So a good number.
That's awesome.
Okay, outstanding. And there's very good reasons to do that. And this is one of them right here. HA is a whole lot nicer in 5.0, thanks to Keith and the rest of the team down here. So great enhancements. But anyway, the heartbeat section there, when you enable HA in your cluster, it will look for a couple of data stores, two, by default, to start that heartbeating mechanism there. And typically it will favor data stores that have the highest number of connected hosts to it. So now best practice would have it in a cluster that all your hosts are configured the same from a storage perspective, but if that is not the case, the heartbeating mechanism in HA will favor storage connected storage that has the most hosts connected to it, I guess is the best way to put that. And if you were to dig down a little bit further onto that storage and kind of browse the file system down there, you'll see evidence of this heartbeating, such as what's shown on the slide there, the screenshot there. You'll see that FDM folder underneath .vSphere HA. And a handful of files down there. We're not going to dig into what each one of those files do at this particular point. That's probably a better offline discussion. But if you have questions around that, we'd be happy to answer those for you. But just wanted to give you a glimpse of what you're going to see on that heartbeat data store when you enable HA. So that does lead to a best practice, though. Yes, sir. Quick question. So that's actually what I'm going to cover right here. In most cases, it's probably not going to be that important to know. HA does a good job of configuring that by itself, which is good for most of us out there. We don't want to necessarily get into too much manual configuration for a lot of different reasons. But there may be a situation where you have multiple types of storage connected to your hosts out there. And maybe you have one very highly available piece of storage, very fast, highly available, very redundant. And maybe you have another piece of storage that is maybe more for like ISOs, kind of like in the example that I'm showing on the slide there, which may not be as highly available or have the redundancy that the other storage frame or frames has. Hold on one second. Let me finish my thought and I'll get to your question there. So in that particular situation, we want to make sure that we utilize those highly available frames for that heartbeat traffic. So in that particular case, that might be where you dig into the interface there a little bit and set a preference to utilize these data stores versus maybe that ISO data store, simply because of the additional resiliency underneath the hood there. So question here?
Right. Real quick, it is important to know which data stores are being used, but you should never need to go into that data store, into that subfolder. I believe there's only one human readable file in there, and you'll never need to use it. Even for troubleshooting in support, we won't need to use that with you for the most part.
Gotcha. Question here. Yes, sir.
It's kind of obvious, but what you're saying is right now we don't need host-to-host heartbeat connectivity if there's for the data store.
So the question was, we don't necessarily need host-to-host connectivity, and the answer to that is no, that's not the case. We definitely need that host-to-host connectivity there. As a matter of fact, that's the primary channel for which HA talks, is across that management network. The heart... Oh, through the storage network. So repeat your question again. We don't...
Yes.
Correct.
Yeah, so think of it as an additional way of being able to tell an HA event. So it uses the files on the data store, not host-to-host. That's storage key.
Yeah. So you had to clarify on that. There's no need to change the way you do. Yeah, that is a good question. You're right. There's no need to change any type of zoning. So we're not actually communicating through the storage network. What's happening is there's the common storage, the shared storage down there, and there are files that are touched by all of the hosts in the cluster. So again, no need to change the way you do your storage provisioning to your host today. HA will work with what you have by default. So.
Okay, so let's get into some more deeper details of HA. First, we're going to talk about HA events. So HA events happen in three main ways. And these are what happens on the host. That's what we're talking about on this section. At the end, which as it looks like we're definitely not going to get to. There's other ways HA can kick in regarding VMs and application events, but these are host events, okay? The first one we're going to talk about is host failures. This is what you probably most commonly think about when you have an HA problem. This is the host is down. The host is hard down. Power was pulled. It's PSODed. It's, in all intents and purposes, just not available for you. Okay? So the recovery from this is VMs are powered up on the remaining hosts based on the restart priority, which is high, medium, low, or disabled. And then you can set that per VM. All right, so that's host failures. Very basic, don't really need to spend a lot of time on that. The next one is network partition. And we're going to spend a little more time on that one today because this is a new concept with FDM. This is when a group of hosts are split into isolated islands, but they can still communicate to each other. They still have access to their storage. They just can't talk to the rest of the FDM environment in general. Okay? This was introduced to really address more complex scenarios, complex environments of maybe a metro cluster or a storage cluster when all hosts aren't necessarily in the exact same site, but maybe let's say they're in different racks. And I have some diagrams we'll talk about next, and why don't we dive into that now? So let's say, I'm a very visual person. I like pretty pictures, and I like making little animations and stuff. So I did that for you here today. So let's say we have this very simplified environment. We have hosts at the top, we have switches in the middle, and we have a core switch at the bottom. That's my simplified idea of an environment here. So again, these could be different campuses. They could be different buildings. They could be different racks, too. So let's say life is all good, life is going on, but then oh, sorry, I forgot to tell you about, it is an HA cluster. So there is one single master there on the far left in the orange box. That'd be kind of cool if all servers, had an orange box if it was a master. So let's say we have a lightning bolt event. That's what I'm calling it here. Some clip art comes down. It knocks out the little network segment in between that core switch at the bottom, and let's call it like an access switch in the middle.
I hate it when the clip art comes down like that, guys.
Yeah, there's a better one in a couple slides too. So the key to get across to you guys here is the hosts are still online. That switch is still online. Those hosts can still talk to each other. Okay? So what happens is that's considered network partition. That group on the far right is a new partition of the network. The recovery from this is a new master is elected. So right now we have the master on the far left in orange that we had before, and a new master was elected. The reason for that is so that so your environment can still continue, so it can still function while it's in this situation. And let's say one of the hosts in the background there goes offline. That one has a host failure while it's in this network partition. That new master will be able to power on those VMs on surviving hosts. Okay, so it's a good way of responding to complex environments. But additionally, it's not just one partition. It could be multiple partitions. So let's say that lightning bolt was accompanied by, a big cloud, although I shouldn't use that term in this industry, but a big rain cloud comes down and it takes out your switch on the very bottom. So those switches now can't communicate to each other. Those group of hosts can't talk to each other either. So you have multiple network partitions in this scenario. So another master is elected. HA can continue functioning in this state for a while. All right? Anything to add to that, Jeff?
Perfect.
All right. So host isolation. This was available in previous versions, so it's not very new, but we will talk about it a little bit. This is when a host, it can no longer ping its gateway, so it's isolated. It has access to its storage, but it can't talk to any other FDMs. So it's isolated on its own little island there. Okay? So the recovery from that is based on your host isolation policy. There's not just one thing that happens in response to that. You can configure the response to that. So there's 3 options that you can configure: leave powered on, power off, and shut down. These are not really well understood because we get a lot of questions on this about what's the best policy to choose, right? Because we've even changed this as defaults in our software over time. For a while it was shut down, maybe it was also powered off, and that might have caused grief in your environments if you had some network problems in your VMs. How many people have encountered that in the past when it was the default setting?
Yep.
Yeah, maybe that wasn't best for you, and that's what we're going to talk about is what is best for you. So right now in our software, it's leave powered on is the default. Okay? So what I was segueing into was which policy is best for you. And well, the thing that most architects respond to, maybe Jeff responds to in his marketing spiels also is, well, it depends. It depends on how you want to avoid these problems. There's not just one solution. Okay? Something that we come up with in our documentation, if you read through it really closely, is likelihood. And that's one way that we can explain how to come to the best practice for you for this policy. So, and when I say likelihood, kind of an odd word that I pulled out of some of our documentation, it's the likelihood of something happening in your environment. So let's say you have a storage array that's been starting to age over time, right? You've had some failures. Your storage guys can't figure it out yet. Or maybe you have budget to buy a new array next year, but it's not next year yet. So you have question marks against your storage array. So it's likely you may have a storage problem in the next few months. Okay? So similarly on the network, let's say it's likely your storage guys have been slacking off. They've been chasing some ghosts in the network, in VLANs.
It's always the networking guy's fault, right?
Yeah, or the storage guys. I mean, come on. You guys are VM admins. You don't do, well, I'm sure some of you have to do it all. I'm sorry. That's no fun. But anyway, I mean, so it's likely you could have a network problem sometime in the future. So what we can do is we have this table in our documentation, and don't worry about reading through it all right now. We're going to walk through it one scenario at a time. And this is a way to really come to a recommended policy, because we can't say, well, this is what you should do in this scenario. This is a way of getting to your own recommendation for your environment. Okay? So the first column here is, what is the likelihood that I'm going to retain access to my data stores? Okay? So your data stores either will or won't be there depending on your storage guys and what they're doing. And it's the same thing with the network. What's the likelihood that I'm going to retain access to my VM network? And that's what we're getting across here. Remember, isolation response comes into play when the host is isolated. The management network is having a problem. Okay? The VM network, is that having a problem? Is it not having a problem? Okay? That's what we're talking about. That's key here. So first row there. So it's likely that I'm going to have a problem with, the inverse of that. So it's likely that I'm going to retain access to my data store, and it's likely that my VM network is going to be fine. This is probably the most common one because it's just the management network that's having a problem here. So it's likely my VM network, my data stores are fine. So in that case, leave powered on, because nothing really is affecting the VM itself right now. It's just the management network. So why introduce a problem, right? Why have to power down the VM? Why have to power it up somewhere else? Okay? Leave powered on in that scenario. Let's switch it around a little. Let's say it's unlikely my VM network will retain access. So this is the scenario where the VM network and the management traffic are probably shared on the same physical link. Maybe it's on the same vSwitch, same actual physical switch, what have you. It's shared and not physically separated. So when the management network has a problem, the VM network's going to have a problem too. So it's unlikely I'm going to retain network access, but my storage is fine in this scenario. Now this one, the recommended policy in this scenario is leave powered on or shut down. That may seem kind of counterintuitive because they're very different actions. Leave powered on may be recommended when it really means what's going on inside the VM itself. So what's the workload of the VM? Maybe the VM doesn't need constant network access. Maybe it's a cluster member. It's a member of a cluster, and the other cluster members can pick up and continue functioning when you're in this state. So leave powered on. It'll just sit there. It'll be off the network for a little while. Or conversely, if it absolutely needs network access, web server, Exchange server, what have you, shut down. And that's shutdown initiated via VM tools so that it's a graceful shutdown. It'll power up on another surviving host, right? Leave powered on or shut down. Let's make it a little more complicated. This is possibly an edge case, but a very important case to talk about. So it's unlikely that I'm going to retain access to my data stores in this scenario, but my VM network is still available. Now, let's say a host loses access to its data store. What happens? The locks on the files are removed. So the VM, in this case, is still, or could still be running in memory, still functioning, still available on the network. If possibly the VM gets powered on another host, what happens? You have two VMs on the network, the same name, same SID, same IP. That's not a good scenario. It's not a good scenario at all. So we would recommend power off in this scenario because you want to get that VM down immediately.
And I think a graceful shutdown would be next to impossible if there's no access to storage as well.
Exactly. Yeah, I guess that's not implied. I was implying it. Yeah. All right. So let's move on there. So I didn't have a good way of segueing into this one because I segued into isolation policies. But let's switch gears. Let's talk about emission control. This is a very common question, a very common customer problem because, well, the first emission control policy isn't very well understood at all, and maybe the concept of it in general isn't understood very well either. So what this is emission control is what really protects yourself. Protects you from shooting yourself in the foot by powering on more VMs than you have capacity to fail over in the event of a problem, right? How many people have actually encountered that problem? So like you power on too many VMs and something happens, all of a sudden you can't power them all back on. That's not a good situation to be in. So it protects you from yourself is how I like to put it. So we have three policies that you can choose from. Static number of hosts, percentage of cluster resources, dedicated failover hosts. All three of these are very different from each other. They work in very different ways. So we're going to dive into these if we have time. The first one, static number of hosts. This is, I'm going through these in order, so it makes more sense when you're looking at the client so that you remember what they are. This one, and I mentioned the order because this used to be named cluster failover tolerates or something that was pretty awkward.
Pretty not intuitive.
Yeah, and I can explain how that name works. It wasn't always very clear. So one of the things they've done, they've renamed it a little bit, static number of hosts. This basically means how many hosts do you want to tolerate losing in your cluster? So by default, one is selected, one host. So we're going to not set aside a single host. That's a different policy. We're going to set aside the resources of a host. So the amount of resources that are being contributed from a host is going to be saved in the cluster in general. So you can tolerate losing a single host. And the way this works is by subdividing your environment, your entire environment of compute resources, CPU, memory, into a concept that we call slot sizes. So when you hear the term slot sizes, which I'm sure you've heard a lot, that's the one that has to do with number of hosts. And, there's that old name, host failure cluster tolerates, which I was getting at before. So this is the single one that uses slot sizes. The other ones do not. This is the only one. So remember that. So because slots are a very misunderstood concept, and working in support when I was first hired there in the VI3 days, we actually had to compute this by hand with customers to be able to explain how slots worked. I'm not sure if Keith knew that, the developers knew that. Possibly they did, because now we show the slot details in the GUI, which I'm going to show here with this scenario. It's very handy. I wish we had that back then. It was very difficult because customers couldn't really, you couldn't tell what your slot size was, and it was hard to realize, why can't I power anything on? I have all these resources. My CPU and memory is only right here, and I can go to here. This is why, and we're going to walk through why. So let's say we have a cluster of hosts. Don't pay attention to the number of details up there. I only illustrate those so that mathematically my scenario works here for you if you want to carry the one and check it out. But let's say we have a cluster of hosts. It has so much memory, so much CPU, and we have 2 VMs. Now these two VMs in my environment, they each have reservations on them. One has a higher CPU reservation, one has a higher memory reservation. Very simplistic, very small scenario, but it illustrates how it works exactly. So what HA does is we take a combination of your reservations here. So we take the 2 gigahertz reservation, we take the 2 gigabyte reservation, and we set the slot size based on that. So your slot size is your worst case scenario of a VM in your environment. So it's a generalized representation of a VM in your environment. So this is the HA tab that I was mentioning that is very handy. It's very nice to know what your numbers are looking like. So let's walk through what each one of these numbers are, because it's not entirely intuitive or very clear when you're just glancing through your interface. Excuse me. So let's say we have those 4 hosts that I mentioned. So this is the real world scenario, even though it's very minute. So we have 4 hosts in the cluster. 4 hosts are marked as good hosts. They're contributing resources to the cluster. This number would be lower, let's say, if the hosts were in maintenance mode, they were disconnected, the agent was having problems. These are the number of hosts contributing to the cluster. Those are the good hosts. So we take your slot size, we divide that into your total resources in general, and your number of hosts, and we get to 12 slots in the cluster. So right now, this cluster can total capacity contains 12 slots. So let's say we have those 2 powered on VMs. The 2 that I'm mentioning have reservations on it. So okay, so 2 powered on VMs, great. 3 failover slots. This is the indicator of how many slots are set aside for failover. Exactly what it sounds like. Because the default is 1, and in my scenario, I left it at the default of I'm able to lose 1 host, it's very easy to tell how many slots are being contributed per host. So right now, there's 3 slots being contributed per host. I can tell that by this screen here. It's kind of nice to know. So if you subtract it out there, 12 total slots minus 2 powered on VMs minus the 3 failover slots, that leaves 7 available slots. So I can power on 7 more VMs before HA yells at me. How many times have you had HA yell at you? Can't power on any more VMs? Oh, really? I see that a lot more than that. Come on, guys, really? And what do you do after that happens? Yeah, you go and disable emission control. Yeah, power on more VMs.
And HA's out the window, and we're in a bad place.
Oh, there's a reason why it's here. It's protecting you. No, that's a different story. So I wanted to illustrate where you set this up in the GUI, and I wanted to illustrate some of the changes here. So at the very top is the Windows client. So I forgot to mention earlier, all the screenshots in here are from the brand new web client. If you haven't seen it yet, that's what they mentioned in the keynotes. Go check it out in the booth. We have a very big VMware booth with all the demos and stuff. There's one for web client. Check it out. Play with it. It's great. I like it a lot, but it's a big change. It's a big change because you're used to doing it in the Windows client. It's really good, but you really need to play with it before you need to rely on it. Okay, that's just my spiel because I'm involved in that group also.
15 minutes left.
Yeah,
You're fine. You're fine.
So we wanted to show you at the top, that's how it was previously. But now in the new client, we have a new section. Because previously you could only configure how many hosts you're leaving failover capacity for. Now you can set the slot size by hand in the interface. That's great, right? Maybe you're an astute admin and you read our documentation every night before bed. It's good bedtime reading. Maybe you knew that you could do this previously with advanced configuration options. There's a very key difference in this behavior if you're used to doing this. The previous behavior was it was a cap on the slot size. Let's say you had a ton of reservations and you wanted to lower the slot size quite a bit. That's why you would use this. But then time passes, you remove all those reservations, and the slot size will drop. It'll drop below this. This isn't an exact value. This is a cap. The different behavior is in the new client. In the new web client in 5.1, this sets the explicit slot size. So that'll take effect when you configure this. It's not a cap. This is more intuitive. This is what you would expect, but it is different behavior than previous.
And I guess there's a good reason to point out why we're covering this in a little detail here. What we're talking about is a situation where most of your VMs may be within a common size, give or take a little bit. So the example that Josh had used there around 2 gigahertz and 2 gigs of memory, that may be the average size of your VMs across the board there. But you may have that one VM out there that could potentially skew that slot size because it's an exceptionally large virtual machine with reservations on it. For example, I have a database virtual machine out there that has 16 gig of RAM, and I've reserved that RAM as well. That could drastically skew that slot size, meaning that the number of available slot sizes in the cluster goes down quite a bit, and at that point we get into a situation where we can power on fewer virtual machines until we hit our head on that admission control policy. So that's why it's important in some cases. Now again, keep it simple, stick with the defaults unless you have a reason to go in there and change this setting, but that may be a situation where it makes sense to go in there and modify that default slot size that the HA cluster calculates because of that one off virtual machine that has an exceptionally large amount of memory reserved.
Yep. And I wanted to illustrate how changing the slot size affects your cluster, just so to kind of press the point. So let's say we had the same environment, we had the same scenario previously, 4 hosts, 12 slots. See the slot size there on the top right, that's 2,000, whatever megahertz, 2095 megabytes. So that was your slot size. Let's say, well, I want to bump that up because I want to ensure capacity or failover, for certain VMs. Let's modify it by hand in the GUI. So we're bumping it up. We see it's a little bit higher, previously 2,000, 29. So it's a little higher, not drastically. But in this simplified situation, it does have an effect on my cluster. It now drops from 12 that I had previously to 8 slots in your cluster. And you'll see down below, when I was harping on the number of failover slots, that's the number of slots contributed per host, that drops to 2. When previously it was 3, now it drops to 2 because my slot size is higher. Okay? And there is a lot more deeper details in here, which we're really not going to have time to go into. Whether your cluster is balanced can affect this, whether you have the same amount of memory on every host, things like that. There are more we can go into, but it is what it is in a short presentation. So to recap, we're talking about the static number of hosts policies. This is the one of 3 policies. The other 2 are much more simpler, and I'm not going to talk for 20 minutes on a single policy for those. So the other ones are % of cluster resources. So what this does is you can specify a number, a % of resources, not number of hosts. So a % of resources per CPU or memory that you want to reserve. Previously in 4.0, I believe, when we introduced this was a single value, but we realized it didn't really make much sense to your environments because you're usually more memory constrained than you are CPU constrained. So now, starting in 5.0, I believe it was, that it's split out now, CPU and memory. So to illustrate how that works, the 25% is configured there. So on your HA protected graph there, it just ropes off that 25% on the side. All right, so if I'm feeling really conservative as my business picks up a certain time of the year, let's say I just really want to move it up to 40% from the 25 because I really want to have failover. But unfortunately, you probably can't tell on the PowerPoint over there. Maybe you can. But my current running workload actually was higher than that. So what happens if I try to power on any more VMs? That error message that I mentioned before. Insufficient resources to satisfy configured failover level. Then you go and disable mission control and ignore mission control in general. So it's important to note that VMs are not powered off. Nothing happens to your environment. Nothing breaks. you just can't power on anymore if you were in this situation. And the last one real quick is dedicated failover hosts. That just takes a host, sets it aside. It's not a cluster. It's not considered for calculations for DRS or anything else. It just sets it aside. So you can do one host, multiple hosts. Maybe that'll work out best for your environment. So commonly, we would then be asked, which do I use? I have all these choices. I don't like choice. Tell me what to do. Well, as a company, and we really do have a recommendation for you on this one, and that is the percentage way. Because we think that doing the calculations, doing the calculations by hand and really tuning that value down is best for environments in general. But for your situation, maybe it's different. This is what we recommend. So a little quote there from Frank Denneman and Duncan Epping. Definitely check out their clustering book. It's great. I like it a lot. The quote there, do the math, take the customer requirements into account. If you need flexibility, the percentage is the way to go.
And by the way, credit where credit's due there. They just released the latest iteration of that particular book. If you haven't seen it out there yet, there's an updated version for 5.1. If you're wanting the nitty-gritty on some of the details that we kind of went through here, and again, we had to leave out some good information just because of not enough time. But if you really want to dig into how this stuff works, that's a good book. I read the 4 version, I read the 5 version, and I'm in the process of reading the 5.1, and that spells it out very well. And needless to say, we referenced that book for this conversation as well. So great resource if you haven't seen that yet.
Go into questions?
Yeah, yeah. So we're just about out of time. We're not going to get to the last few pieces there as far as the application and VM protection that's available in HA. Again, there's tons of details around that in the book we just talked about. We definitely wanted to leave just a few moments for Q&A though. And again, before we get too busy and folks start heading out too far, again, if you have questions and we didn't get to those questions or we're out of time, Josh and I plan on being down in the demo booth from 4 to 5. Feel free to stop by and ask your question then. But we do have a few minutes, about 7 or 8 minutes for questions here. Any questions out there? Josh, you want to? There's one right here.
Oh, I did see. Yeah, shoot.
I don't believe that plays into it at all.
I don't think so. Yeah.
Keith, any comment on that? So the question was, does memory overcommit play into the way HA works in any way, shape, or form? I don't believe that it does. So the question was, will overcommit be utilized in an HA scenario? And I guess to answer that question, yes, if it's allowed to. But if there are reservations, it's not going to violate that reservation on that VM.
Yeah, that's key. Yeah.
Thank you, Keith. Question down front here?
Yeah. Let's say 50 VMs and also 2 gig memory. You do have those ones that are 32 gigs, but we're not using reservations. How does that actually work?
It's not.
So repeat the question.
No, the question was, let's say I have just a single VM that's much larger than all the others, right? Very common, very common. Yeah, it's only for the first policy, it's only reservations. Yeah, I had that question at our expert booth yesterday. Yeah, definitely. Yeah. So in that case, you would want to set it by hand if you use that policy or percentage. That's why maybe we recommend the percentage to be the way to go.
Yeah, so now with the distributed virtual switch, so the question is, there's a corner case scenario where you could have some issues with the distributed switch and HA. You now have the ability to roll back that distributed switch to fix that issue. Is that what you're talking about?
Well, it was when the VM was stored in motion
Yeah.
data store.
It's connected to an invalid port on the
Yeah.
Oh, gotcha. Okay, gotcha.
So if the host that was running on failed, it would try to restart it elsewhere and it would work.
Yeah. Yeah, I believe so. That's fully addressed.
Yep.
In update 1.
I take it you got bit by that.
Oh, yeah.
Okay.
No, that got a lot of attention. Yeah, I know. And she's our development team's very well aware of things
Gotcha.
like that. Yeah.
I was thinking if you made a change to the distributed switch, were you able to? Gotcha. Go ahead. Understood. Next.
Does the startup order and HA play into each other? If you have a whole host together, all of
The
them have to start up on that host, is it taken into consideration in order, or is that only set for that host for normals?
So the question was on startup order, and you're talking about for the on the cluster, right? It obeys the priority, not the startup order configure. That's in a different tab, I believe, right? Yeah.
Yeah,
The exact order is, yeah, when it's added to a cluster.
VM, it drops out and defaults to the bottom every time.
Yep.
Does that happen with HA? If that drops to the bottom and you forgot to move it
Yeah.
back up into the high
Yeah.
or the top
Yeah,
during HA, would it just sit there and not turn on?
correct, because it's not added to the configuration of the VM. It's a per host.
Every time you demotion a VM, you have to go move that up. That hasn't changed. So I'm not defined.
Go ahead, Keith.
I guess I'm sorry I didn't really follow your initial question, but the restart priority, is it, you can either set it in the cluster as a default, or you can set it on a per VM basis. So
Yeah.
if you motion into the cluster, it's going to take the cluster default that you set up.
I'm just in a weird scenario where I run VDI in the same cluster, so I can't have all my VDI VMs on automatic turn on.
Yeah.
So I set it to off, and then I have to go to every VM and say, yes, you are going to turn on. And then I have to set it to order. So if I demotion it, it goes to the bottom. And then if I forget to turn it on, so there's no way to kind of say, okay, if you change host, you still are going to start up first.
But you need to change host to change the cluster.
Host.
No, this is a cluster setting, not a per host setting. So therefore, as long as it's the same cluster, that override still going to apply to that region.
That's what I thought. Yeah.
Would it be a way to, because now the startup setting is just firing power on. But it can even, so the high priority and normal priority, it just fires the power on. But you can easily have that a normal powered on machine
Yes.
already working,
In,
while the high priority is still starting.
yes, Frank and Duncan illustrate that in their book with diagrams, I believe. Yeah.
Or maybe in 5.2.
Sorry, I didn't repeat the question.
To really make them wait. Because I have
No.
a badly written application that can't recover from being up first and then the SQL database being up later on.
Oh, okay, gotcha.
So the question was the startup priority of high, medium, low. A slow starting application or VM rather that is high priority, a low or medium priority may be turned on actually before the first one, right? The actually important one. Yeah, that the priority is based on the initiation of the startup. Yeah.
We are looking at what we're looking at is more dependencies, right? And we want to make sure the dependencies are up before the other VMs are up.
Because the VMs, they have that, they wait for the VM machines.
Yeah, so I think for the future, we are looking at ways to improve the app level, startup ordering, and dependencies.
So stay tuned.
All right.
Working on it.
I don't know who's been waiting longer. Let's go with this guy.
Storage heartbeat.
Storage.
So if I have the data source set up for storage heartbeat and that gets offline on the SAN side, all the hosts can't see it at once. Is there an election process? And if so, what is the election process underlying?
Are you saying that the cluster is in a good state?
The cluster is in a good state, but the heartbeat, HA, data storage is offline on the SAN side.
It's not used. Yeah.
Okay, so if one selects a new data store, is there a particular metric it uses or?
Is it 5 minutes by default, like for NFS, for example? When it tries to touch the file, is that how that works? Yes, exactly.